Hi everybody, welcome back. We are going to do some multiplying and dividing of fractions today. So if you're in junior high or high school, early high school, you may be uncomfortable with fractions. Unfortunately, they do not go away. The more math you do, the more they come up. So you have to learn to be comfortable with fractions. Fractions are just parts of whole numbers. There's nothing to be afraid of, okay? A lot of teachers will actually tell you to get rid of the fractions. Sometimes you can't do that, but they're not evil, okay? So let's start with an example. So when we're multiplying fractions, what we do is we multiply along the top and we multiply along the bottom. We do not cross multiply, okay? Cross multiplying is something that happens when you have an equal sign, and that'll be the subject of a different video. Yeah, it's not the same thing, okay? So 1 times 1 is of course just 1, and 4 times 3 is 12. Now what does this mean? Let's have a look at an example. So if we take this box and divide it into fourths, so we have 4 parts, right? And now we want to take 1/4 of that and multiply by a third. So what we're saying is, what is 1/3 of 1/4? So if we take this section here, which is 1/4, and divide it into thirds, we have something that looks like that. Now, right now that doesn't make a lot of sense, but if you pull these lines across, you'll see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12 parts. And when we take that 1/4 and divide it into thirds, what we end up with is 1/12. Okay? Because 1/3, here's 1/3, 2/3, 3/3 of 1/4 makes 1/12. Again, it's helpful to have a common denominator, so to speak. Though you don't need one to actually multiply fractions, it's not necessary. It's helpful to think of like-sized pieces. So 1/4 of 1/3, or 1/3 of 1/4, it doesn't matter which order you multiply things in, is 1/12. All right, so that's that one. Lots of examples. 2/3 times 1/5. Okay? Again, we're just multiplying along the top and along the bottom. So this is just 2/15. How about this one? 3/4 times 5/6. Now when you're multiplying fractions, we could write 15/24 here. That's fine, and it's not wrong. But you're always going to want to reduce your final answer, okay? So if we do it that way, if we write 15/24, then we have to say, oh, you know what, there's a common 3 there, okay? And that 3, if we divide the 15 by 3, we get 5, and if we divide the 24 by 3, we get 8. Now, this is a bit more work than I have to do, though, because the 3 and the 6, which have that common 3 that I just divided out of here, could be divided out before I multiply, okay? And the way we do that is we just say, well, the 3 and the 6 can each be divided by 3, so we're going to divide the 3 by 3 and get 1, divide that by 3 and get 2, and then do my multiplying. So 1 times 5 is 5, and 4 times 2 is 8. So one thing about this one, what you could do, so you could write it like this if you wanted to. It will give you the same answer. It says the same thing, okay? You could rearrange the terms so that it looks like this. You could then pull that apart. This is just a way of understanding it. This is not something that you would typically do. Okay, now you look at that and you say, well, why would I multiply 3/6? Why wouldn't I start with a smaller number, the equivalent fraction, which is 1/2? Doesn't that make more sense? The 5/4 is not reducible. And then multiply this, and notice that we get the same answer that we got up here. Okay, so this is what we mean by canceling, right? So, or reducing before multiplying. Always look for opportunities to reduce before multiplying because it's just easier. Because you're going to have 1 times 5 and 4 times 2 versus 3 times 5 and 4 times 6, bigger numbers. And then you don't have to reduce when you're done, okay? Also, looking back at this one, if there are no reductions possible before multiplying, then there won't be any possible after multiplying either. So, you know, the 2 and the 5 have nothing in common, the 1 and the 3 have no factors in common, and it's worth mentioning that the 2 and the 3 and the 1 and the 5 don't either. Though typically we don't get this, you know, we don't get 3 over 6 to multiply. More likely the 3 and the 6 would appear in separate fractions, okay? All right. So this one has a little bit of a twist. When you're adding and subtracting fractions, you can always add mixed fractions or subtract mixed fractions if you happen to have them. There are instances where it can be awkward, but it can be done and it's mathematically possible to do so. It is not possible for multiplying fractions, okay? When you're multiplying fractions and you have a mixed fraction, it must be turned into improper form. It has to be before you start, okay? So 1 2/3, what we want to do is we want to say, well, how many thirds is this? Well, if we have one full one here, okay, so we've got 1 and 2/3, then what we have is 1, 2, 3, 4, 5 thirds. Now, the way you do that without drawing it out is you go this times this, so that's 1 full third. So 1 times 3 is 3, plus 2 is 5. So there's your 5 thirds. And here, the second twist is the fact that we've just got an integer here and not a fraction. Now, don't let this throw you. It throws a lot of people. If you need to, put it on 1. Okay, every number is on 1, essentially. You don't have to do this, you don't have to write it over the 1, but what a lot of people will do is think that this is equal to that. Okay, they'll think that the 4 and the 3 multiply as well. They don't. Okay, that is wrong. So again, we multiply along the top and along the bottom. So that is not correct what I've done here, okay? So 5 times 4 is 20. And 3 times 1 is 3. Now, if you're in earlier math class, if you're in junior high, grade 8, grade 9, you would be expected probably to turn this into improper, mixed form rather. How do we do that? Well, we say how many times does 3 go into 20? If you're shaky with your times table, practice it. 3 goes into 20, so here's what you can do to kind of get there. Okay, so we have 6, we have 9, we have 12, we can keep going, right? 15, another 3 makes 18, and we're not going to get another 3 in because if we go one more 3, we're going to get to 21, and that's bigger than 20. So we have 1, 2, 3, 4, 5, 6 3s in 20 with 2 left over, right? Because 6 3s make 18, so this is 6 and 2/3. So the way you do it is you say, okay, how many times does 3 go into 20? It goes in 6 times. 6 times 3 is 18, therefore there's 2 left over, so we write 6 and 2/3. If you're in a higher math class, grade 10, grade 11, this would not be expected of you anymore. However, there is still some work done with mixed fractions, especially when you get up into grade 12. Grade 12 trig uses some mixed fractions. Okay, this one's nice and simple. 2 times a third. If you have a third of a pie and somebody gives you another third, you've just doubled how much pie you have, don't you? Don't you have 2/3 now? It's really that easy, okay? 2 times 1, 1 times 3, and we end up with 2/3. So this one's got 2 mixed fractions, and as I said before, we have to change mixed fractions into improper form before multiplying. There's no way to do it any other way. So if you try it and you happen to get the right answer, it's just a fluke, okay? 2 times 4 is 8, plus 3 makes 11. So we have 11/4, okay? And times, 1 times 9 is 9, plus 1 is 10. We have 10/9. Now earlier I said look for opportunities to reduce. The 4 and the 10 are both divisible by 2. So let's do that. The 4 divided by 2 gives us 2, and the 10 divided by 2 gives us 5. Okay? And now we just multiply what's left over. 11 times 5 is 55. 2 times 9 is 18. Alright? So that's that one. So when you're multiplying 3 fractions out, it's no different from multiplying 2. So first of all, let's turn this into improper form. So 2 times 3 is 6, plus 1 is 7. There. And now we reduce what we can. So the 3's, they're just gone. And what are we left with? Well, we're left with 1. Because what we've done is we've divided both of those numbers by 3. And then we multiply the top 3 numbers, giving us 7, and the bottom 3 numbers, giving us 8. And that's your final answer, okay? If you didn't notice that there was this common 3 here, then what you would get is 1 times 7 times 3 is 21. And 2 times 3 times 4, we have 6 times 4 is 24. And then you would say, well, look at that. There's a 3 in both numbers. So then you would take the 3 and divide it out of the 21, giving you 7, and take the 3 out of the 24, giving you 8. So you're going to get the same answer, but it is easier to reduce beforehand. So train yourself to notice, to look for those opportunities to reduce. Okay, so that's it for multiplying fractions for now. Now we're going to do some dividing of fractions. So let's start with this one. Quarter divided by 1/2. So the method for dividing fractions is to take the fraction that's doing the dividing and flipping it, okay? We call it the reciprocal, and the reciprocal, all it means is that the numerator becomes the denominator and the denominator becomes the numerator. We just flip it, okay? And then we multiply, just like we did in the first part of this video. So the 2 and the 4 become 1 and 2, and we get 1 over 2. Okay, that's all there is to it. Let's look at this one, 2 over 3 divided by 1 over 6. Same method, it's 2 over 3 times 6 over 1. The 3 and the 6 can reduce because they have a common factor of 3, okay? So we're going to divide this by 3 and get 1. We're going to divide that by 3 and get 2. We're going to multiply and get 4. Now because the denominator is 1, we never write that, all right? There are high school math teachers that will take marks off if you put an integer over 1 as a final answer. It simply isn't done, okay? If you have a niece or a nephew that's 4 years old, you don't say they're 4 over 1 years old. You just say they're 4 years old. You don't need the 1. It's implied in every number anyway. Even that 1/2 is standing on 1, okay? So just as with multiplying fractions, when you have mixed numbers and division of fractions, you cannot do that with mixed numbers. It has to be first converted into an improper fraction. So an improper fraction, in case the wording is unfamiliar, the top number is bigger than the bottom number. That's what it means. It's a fraction that essentially is greater than 1, okay? So 2 times 2 is 4, plus 1 is 5. So we've got 5 over 2 divided by 1 over 2, which is 5 over 2 times 2 over 1. Okay, we're going to get a lot of these ones because for some reason we divide by fractions a lot that have 1 in the numerator. So you're going to get that 1 in the denominator fairly often, especially in the earlier grades. And then the 2's just cancel away because 2 over 2 is equal to 1, and we get 5 again, okay? And let's carry on. 2 3/4 divided by 1/4. So for this one, again, make your improper fraction first. So 2 times 4 is 8, plus 3 is 11 over 4. So 2 3/4 means we have 11 quarters. So again, Okay, if we have 2 3/4, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 quarters. So the 2 times 4 means we have 2 wholes that are composed of 4 parts each, so those are those, plus 3 left over, which gives us 11 quarters, okay? And then we're going to flip this one right away, gives us 4/1. These go away, and we get a simple 11 as a final answer. And 2 3/4 divided by 1 1/2. Both numbers must be converted to improper form. So 2 times 4, we had this in the last question. 2 times 4 is 8, plus 3 is 11. Divided by 1 times 2 is 2, plus 1 is 3. So we get 3/2, okay? That becomes 11/4 times 2/3. And now we do our canceling, okay? 2/4 is the same as 1/2. And then what we end up with is 11/6. Now I'm going to show you another way to divide fractions. And this is a way that's helpful in the later grades when you start to get fractions that look like this. They're called complex fractions, but they're not really anything more complex than what we're doing right now. This says 11/4 divided by 3/2. It says the exact same thing that this says. Okay, there's nothing different about it. It's just that it looks kind of scary written out the way that it is. It's helpful to know this method I'm about to show you though, when you have these and when the denominators happen to be the same. Now they're not here, but if they happen to be the same, then knowing this method I'm going to show you is really, really useful. It involves finding a common denominator, just like if you were adding or subtracting. So if we take the 4 and the 2 and say, well, the common denominator is 4, okay, and then write that just as if we were adding or subtracting. Put your numerators, so the 11, this hasn't changed, has it? 11/4 is still 11/4. But the 3/2, we've multiplied the 2 by 2 to get 4, so we have to multiply the 3 by 2 as well to get 6. Okay? And then what we do is we ignore the denominators and we just divide the numerators. And that's the same 11/6 we got a minute ago, okay? Here's why it works. If you got to this point and you thought, oh gee, I'm not really sure if this is going to work, or you're just a little bit uncertain, and you decide to do the flipping anyway, then here's what you'd end up with. I mean, this is still 3/2, isn't it? It's exactly the same as 3/2. So if I flip it, it's 2/3. This is 2/3. And then what happens is the 4's go away because they're the same, and that's why we ignore them here, because if you were to flip that second fraction, they would cancel away. And of course we end up with 11/6. Okay, that's it for this video. If you liked it, please give me a thumbs up and subscribe to the channel and share widely so that lots of people can see these videos and learn all the math stuff. All right, thanks very much. Until next time.